Hello and welcome to this video on finding the square roots of variable expressions. So in this video I have several examples where we're asked to find the square root, the non-negative square root of certain radicands, right? Remember the radicand is just the expression inside the radical symbol. And I just have one very simple rule to show you and demonstrate. Alright, so in each of these examples for this video I have the same instruction, just evaluate each square root. Before I get into this first one, you see I have the square root of, and then this negative 14 to the second power. I want to go off to the side here and just kind of refresh your memory if you've been watching my videos on these square roots previously. When you see this symbol, right, this is called a radical symbol and the expression underneath is the radicand, right? When you see this symbol, the square root of something where x here is the radicand, just represents this x is like this negative 14 squared. Your final result, what this is equal to, is not plus or minus anything. A lot of people tend to write plus or minus stuff when they see the square root symbol. When you see this symbol, the result is the non-negative number. Non-negative number whose square is the radicand. All right. So whenever you see this symbol, the result cannot be a negative number. All right. So very often people make this mistake. So if I bring this, I'll bring this example over here. So when I'll say don't do this. All right. When you see the square root of some number squared, very often people tend to just say, oh, this is the square root and a square. These like undo one another, and they just write, oh, the square root and the square undo one another, and I have negative 14. This is wrong. Right? This is wrong. This is a negative number over here. That's wrong. Okay. When you again, I'll say it again. When you see this symbol, the resulting expression, what you yield, should be non-negative. So this is no good. All right. So what we're actually looking for, I'll put this in a box, separate it from everything else. So what we're actually looking for in this example is you think of what's the non-negative number whose square is the same as negative 14 squared. All right. Well, what's a non-negative number whose square is the same as negative 14 squared? That would be positive 14, right? Positive 14 squared is the same as negative 14 squared. So the square root of this negative 14 squared is just positive 14, right? It's the non-negative, it's again non-negative, I'll emphasize that a lot. The non-negative number whose square would be the same as the radicand, right? And what is negative 14 squared, right? You could also have done this, right? Said the square root of negative 14 squared, well, negative 14 squared, negative 14 times negative 14 would be positive 196. And then again, you're doing this, you're just saying, oh, I'm seeing this symbol. This is what's the non-negative number whose square is 196, right? So I'll put or 196, right? Negative 14 squared is 196. And that is positive 14, right? But the result, when you see this symbol, has to be non-negative. Right? So don't just undo square roots and squares, leaving you with negative numbers. That is incorrect. In fact, I'll put up the general rule here with square roots and squares right in the bottom of this page. All right. All right, so let's take a look at some other examples before I establish this rule. All right, some other examples, like what about, what's the square root of 5 squared? Well, that would be the square root of 25, which again, you're thinking of the positive number, the non-negative number whose square is 25. That would just be positive 5. Well, what about the square root of, and then kind of like up here, with, I have, say, negative 5 to the second power inside the radical, in the radicand. Again, don't just undo the square and say this is negative 5, right? It's still the same thing. It's still, what's the non-negative number whose square is the same as negative 5 squared? Well, that would be positive 5. We're going to see this is positive 5 again. So it's the square root of, and what's negative 5 squared? Negative 5 times negative 5, positive 25. And again, the square root of 25 we saw up here. We're asked for the non-negative number with this symbol, the non-negative number whose square is 25. That's positive 5. All right. So just from this couple examples here, you see when I have a positive number squared inside the radical symbol, that's the number that ends up coming back to me. Right? Then you can just undo the square and the square root and say it's 5, because that's non-negative. That's great. But when you have a negative number squared inside the square root, they don't just undo each other. It's not negative 5. Right? Again, you want the result to be a non-negative number. But notice how the result just ends up being the opposite of negative 5, right? Positive 5. Just like my example back up here when I had the square root of negative 14 squared, the result just ended up being the opposite of negative 14. Right. So a quick way to say this, a nice rule we're going to be following here, and this is pretty big, right, is that when you're taking the square root of, say, some number a squared, right, where the square is inside the radical, it's in the radicand here. If a is positive, then it's just like this square root of 5 squared. You just end up with a. But if a is a negative number, like the negative 5 or the negative 14, then you end up with the opposite of a. Well, we'll just, in order to ensure that the result is non-negative, we can do this, say these undo each other, and throw a here, but then just to ensure that this is non-negative, say it's the absolute value of a. Right? So this is, again, absolute value symbols here. So this is huge, okay? Get to knowing this. All right, so when you see a square root with a square inside, they don't just undo each other. I mean, you can start off undoing them, but then you have to make sure that the final result, because this symbol, the final result is a non-negative number, and the absolute value of any real number will be non-negative. Right? Okay, so I'm going to keep this in mind. Right? The square root of a squared is not just a, but we're going to again ensure that it is a non-negative number, say the absolute value of a. So let me keep this rule up top here. I'll go into my next example, and really this doesn't all that much change. My next example is evaluate, what's the square root of z squared. Right. So again, very often people like to do this. They just, the square root and the square. They undo each other, and you're just left with z. That's wrong. Right? Saying the square root of z squared is just z is wrong, as I've mentioned before. And let's check, right? What if z was a negative number? What if z were negative 3? Well, then the left side, you'd have the square root of negative 3 squared equals, and then remember this is the square root of 9, which is positive 3. Remember, whenever you see, I'm going to say this a lot, whenever you see this symbol, this square root symbol, your result should be non-negative. But this is not negative 3, right? But if I plug in negative 3 for z, we'd have the square root of negative 3 squared equals negative 3. That is incorrect, right? So that's why that's wrong. So what we're going to do is instead, right, here's again the right way, the correct way, the square root of z squared. Again, you can start off by undoing the square and the square root, saying you have z, but just to ensure, well, what if z is negative? Well, let's just ensure, that it is a non-negative number by saying, the absolute value of z. Remember, again, this is absolute value. All right. And this works. All right, this works. And try it out, right? Are these two expressions actually equal? Test some numbers out, right? If I let z be negative 3 in this equation, we'd have the square root of negative 3 squared, or the square root of 9, equals the absolute value of negative 3, which is 3. The square root of 9 equals 3. It works. All right. Plug in any positive number for z, any negative number for z, 0 for z, and this will work. The square root of z squared is, the absolute value of z, not just z. Right. And all because of what this symbol means. When you see this, the other side, your final result should be a non-negative number. I cannot say that enough. People make that mistake way too often. All right. So I have another one here. So, and same rule up here. Here I have the square root of, some expression, some number squared. So again, I have the square root of a square, just like my last example, right? The square root of z squared. And just like this, the first example, the square root of, a square, the square root of negative 14 squared. All right. So, here I have the square root of a square, right, where it's like this square root of a squared, but now the a is this expression, 2x plus 3. All right, so again, here's the wrong way to do it. The wrong way is just to undo the square. All right. Say, oh, I got a square root and a square, those undo each other. So I'm just going to say it's equal to 2x plus 3 and leave it at that. That is wrong. And again, the reason it's wrong is because, this 2x plus 3, this isn't always non-negative, right? But if you're seeing this symbol, the result on the other side has to be always non-negative. But this is not always non-negative. Sometimes it is negative, right, for certain values of x. And let me show you. All right, what if I let x be negative 2? If I replaced x with negative 2, would this be a true statement? Let's see. On the left side, we'd have the square root of 2 times negative 2 plus 3 squared. Right, just replacing the x with negative 2. On the right side, I'd have 2 times negative 2 plus 3. And let's see if this is true. So this left side, we have the square root of 2 times negative 2, do in parentheses first here. 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1. So that's negative 1 in the parentheses, but that's being squared. And then the same thing on the right side, this is negative 1. Negative 4 plus 3. The square root of negative 1 squared is just the square root of 1, right? Negative 1 squared is positive 1. Is this equal to negative 1? No. Right? Remember, the square root of 1, when you see this symbol, they're asking you for the non-negative square root. The square root of 1 is 1. And is 1 equal to negative 1? Nope. That's not true. So like I said earlier, just taking the square root and the square inside and undoing those and writing the base 2x plus 3, that's wrong. These are not always equal. This is not always true. The correct way to do it is, again, just to ensure that the other side is always non-negative. Whenever you see this symbol, the result needs to be non-negative always. So the right way, the correct way, is taking the square root of the quantity 2x plus 3 squared, and yeah, you can start off undoing them, right? Undoing the square and the square root, say it's equal to 2x plus 3, but then you have to ask yourself, is this expression always going to be non-negative? And we see when x is like -2 or -3 or -10, you know, this is going to be negative. So just because, because this isn't always non-negative, I'm going to do this, put absolute, say it's the absolute value of 2x plus 3 to ensure that this side is always non-negative. All right. And this is great. All right. This is always true. Right here, this statement. And again, try it out. Plug in -2 this time. You'd get 1 on the left, the square root of -1 squared, which is 1. And then you'd get the absolute value of -1, which is also 1. You'd end up with 1 equals 1. This would be a true statement. Alright, so that's why the absolute value symbols are necessary here when we're undoing squares inside square roots. Okay. Alright, and my last example, I have to again demonstrate to you another common mistake that people make when taking square roots. Alright, I have the square root of, and then this radicand is, p squared minus 12p plus 36. Too often people do this. Again, I'm going to write a big don't over here. Do not do this. Very often people see the square root of a sum or a difference, a plus b, a minus b, and they like to split them up. They say this is equal to the square root of a plus the square root of b. But that is not true. That is not true. For instance, for example, and I put up this example in actually a previous video, so I'm going to kind of rush through this one. Say the square root of 36 plus 64. This is the square root of 100, right? When you add 36 and 64, that's 10. Again, a non-negative number, the non-negative square root, because I'm seeing the symbol. But the square root of 36, if I decide to split them up, the square root of 36 plus the square root of 64, well, what's the square root of 36? That's 6. Plus the non-negative square root of 64, that's 8. And 6 plus 8 is 14, which is not the same, not equal to, a little not equal to symbol pointing up and down here. Is not equal to what I had here. So you see the square root of a plus b inside is not the square root of a plus the square root of b. Alright, so very often people will make this mistake, right? And they see the square root of p squared and they'll just do that and say that's p, and then minus the square root of 12p, and then plus the square root of 36, and they'll say that's 6. You don't do that. You don't split them up when there's a big sum. This is addition and subtraction. You don't split up the square root over addition and subtraction. Please. Right. So what do we do? Well, I want to write this as a multiplication form, in a factored form as a square. All right. So we have something like in our rule here. So we have to factor this quadratic polynomial here, p squared minus 12p plus 36. And I've put up other videos in the past on factoring quadratics. You can look that up, or you can look up other videos on it, or look in your books. But I'm just going to run through this one kind of quickly. I'm not going to go over all the steps of factoring. So this is the square root of, and then p squared minus 12p plus 36 factors to p minus 6 times p minus 6, or the quantity p minus 6 to the second power. Right, that's what it means to have p minus 6 times p minus 6. And you can double check, take p minus 6 times p minus 6 and FOIL and combine like terms, you'll end up with p squared minus 12p plus 36. All right, so now this expression looks like, in my rule here, where I have the square root of a square. All right, the square root of an expression squared, like the square root of a squared here. So the a is like the p minus 6. All right, and as I've done in previous examples, you can start off by undoing them. The square root and the square are undone and you're left with p minus 6. But then you have to ask yourself this question. Is this always non-negative? Right, and the answer to that is no, right? Because what if p was 0? What if p was 0? This would be negative. If p was 1, this would be negative. If p was 5, this would be negative. So because this can actually take on negative values, what we're going to do is, just use absolute value to ensure that that expression is always non-negative, right? So the square root of this p minus 6 squared is the absolute value of p minus 6, right? And again, it's just like the rule up here where this a is the expression p minus 6, right? The square root of a squared is the absolute value of a. The square root of p minus 6 squared is the absolute value of p minus 6. All right, and then go ahead and double check. All right, you can plug in some values. Right. Let's box this in here, bubble it. Let's plug in some values. What if p were 0? All right, what if p were 0? And you can do anything, right? I'm just using 0 as an example, but plug in whatever you want. This side of the equation has the square root of 0 minus 6 squared, and the right side of it, the other side, has the absolute value of 0 minus 6. And then we get on the left side, the square root of what's 0 minus 6, that's negative 6 squared. And then this is the absolute value of 0 minus 6, the absolute value of negative 6. And then the left side, oh, sorry, I'll take this over here. I don't need to throw in a new page, right? The left side is the square root of 36, right? Negative 6 times negative 6 is 36. The right side, right, the absolute value of negative 6 is positive 6, and this is indeed a true statement, right? 6 equals 6. Remember, when you see this symbol, you're looking for the non-negative square root, right? What's the non-negative square root of 36? It is positive 6. Yes, right, this is true. And this should be true. This square root of p minus 6 squared equals the absolute value of p minus 6 for any value of p. Right? Try any value of p, not just 0. Plug in any value of p and they should be equal to each other. Right? But this is huge, right? This rule right here, please do not forget this. All right, when you see the square root of a variable squared or the square root of a square, you can undo it, sure, write a, but then you have to ask yourself, is that always non-negative, right? If you see that symbol, the result has to be non-negative. If the answer is no, then you throw an absolute value around it just to ensure that the result is indeed non-negative. Okay, great. That's all the examples I have for today. And as I like to say at the end of these videos, please try your best to learn the material on your own before you go looking for help. I find that people tend to remember material better and for longer when they've taken the time and the effort to learn it on their own. So, of course, read the material, read the author's examples, perhaps even work out solutions to an author's examples, so try it before you read how the author did it, and then compare your work with the author's and see if you can learn from some mistakes there. Obviously, work on plenty of exercises, practice problems, and of course, check for solutions whenever they're made available. so you can see how you're doing, check your progress. And don't just give up on a problem after one attempt. Very often there are several approaches that'll work for any particular math problem. So if after several attempts, several approaches at a problem or problems, you're still not working them out, you're still not figuring out how to get them, still not understanding the material, perhaps you should read through the material again, maybe even a third time, more slowly, more deliberately, take notes. Because if you've been working on some problems, chances are you have a better idea as to what the author wants from you, what the author is asking you to do, and that'll also give you a better idea as to what to look out for when you go and read the material again. You probably see some things that you didn't see the first time through when you read through it a second or third time. But if after that, if after several read-throughs of the material and several attempts and approaches at problems, you're still not getting it, still not clicking, it is not a sign of weakness whatsoever to go out looking for help. That is what other people are there for. So ask a teacher, a tutor, a friend, someone in your class who you know knows the material well and is willing to help. Look for supplemental materials online. There's loads of it out there. Look for videos on the subjects, such as this one, or plenty of other ones out there that are better than this one. I assure you they're out there and you can find them pretty easily. But just keep at it. Stay persistent. Keep practicing. Don't give up. And I think the hardest thing of all is to try to have a positive attitude about the subject. If you go into something thinking it's going to be boring, that you're going to hate it, well, you're probably going to continue to feel that way while you're doing it and even after. And it's going to make the experience that much worse. So try to have an open mind. Think, when I go into this reading or go into these exercises, that I'm going to learn something today, I'm going to enjoy learning it, I'm going to enjoy working on this, take something away from it for my class or work or life, and just maybe even try to have fun with it. But try to have a positive attitude. And it's amazing the difference that a little tweak in attitude and mindset can make in the learning experience. So stay persistent, keep practicing, stay positive, and don't give up. And I just know that you can get it. And thank you very much for watching.